This video we will solve the kinematics problem for the special case of the acceleration is constant. Before we start, a little bit review for three basic kinematics equation. That is, the first equation is dv by dt equal to a, right? So then when a equal to constant, so we can integrate both sides. From this equation. That is, when time equal to 0 to time equal to t. At time equal to 0, velocity is equal to v0. And at time equal to t, velocity is equal to v. So from this equation, the left-hand side integrate dv from v0 to v is equal to v minus v0, right? And then for the right-hand side, when AC equal to constant, so then we can integrate on the right-hand side equal to ACT, okay? Because the limit of integration is from 0 to t. Okay, so according to this equation, we can rearrange this equation to this equation. As we obtain v equal to v0 plus ACT. Okay, then we use the second kinematic equation, that is ds by dt equal to v. But now v is not constant for this case. We already derived. This is equal to this equation, right? So by rearrange this equation, we have integrate ds equal to integrate v dt. But the time from time equal to 0 to time equal to t. When time equal to 0, s equal to 0, s0. And then when time equal to t, s equal to s. So from the left-hand side, we have s minus s0, right? But for the right-hand side, this is integrate from 0 to t. Substitute v equal to v0 plus ACT. That is come from the first integration, dt. We integrate the right-hand side again, we have v0t, right? Plus a half AC t squared. Okay. So then when we rearrange this equation, we have this equation. Okay. So if S0, if the particles is moved from the starting point, that we may set S0 is equal to 0 when time equal to 0. So then the equation is can be simplified to be this case. That is, when for the case that when time equal to 0, S equal to 0. Okay, so then that means that S0 is equal to 0 for that case. But if not, okay, do not forget to substitute S0 into the equation also. So let's take a look at the last kinematic equation. That is we have VdV equal to AdS. So for this case, when acceleration is constant, we can integrate both sides and we obtain the left-hand side. We have v square over 2, right? From v0 to v. And for the right-hand side, okay, we have ACS from S0 to S. Okay, so then when we substitute the limit of integration, we have this equation v square minus v0 square over 2 equal to AC S minus S0. After that, we rearrange this equation, we obtain this. Okay, and also if for the case that when time equal to 0, S0 equal to 0, so then this is maybe reduced to this equation. That is we familiar with this equation from fundamental physics. That is just a little bit review for three kinematics equation that we have learned from fundamental physics. So then let's take a look the fundamental problem that's for the special case that the acceleration is constant. Okay, so then we starting with this problem. A car starts from rest and with constant acceleration achieve a velocity of 15 meters per second when it travels a distance of 200 meters. Okay, we would like to find the acceleration of the car and time required. Okay, so for this problem, we know from the problem that this is the constant acceleration. This is a constant acceleration, so it means that we can use the kinematic equation that we already derived in the red box. That is this is for special case that acceleration is constant, right? Okay, and then if we review from this problem, okay, a car is start from rest. Start from rest it means that when start is when time equal to 0, right? And start from rest, so then it means that it start from the velocity v0 is equal to 0 because it start from rest. Okay, v0 is equal to 0 meter per second. Okay, and then we know the final velocity v is equal to 50 meter per second. Okay, and we know the final position also, that is s equal to 200 meter, right? Okay, so now we would like to determine the acceleration. Okay, we would like to determine the acceleration and the time. Okay, so then from this from the from three kinematics equation that we know, we have v equal to v0 plus at, right? Okay, and we know that s equal to v0 t plus a half at squared, and also we have v squared equal to v0 squared plus 2a s. Okay, s is mean s minus s0 for the case that s0 is equal to 0, right? Okay, so for this case, how should we start? Okay, we can start if we would like to determine the acceleration first. So then we know v rate, we know v0, and we know s. So then it is better to use this equation, right? So then from this equation, we substitute v equal to 15, okay, square equal to v0, that is 0, right? Plus 2a, a is the unknown, that's if we would like to find, and s equal to 200. Okay, so for this case, we can determine for a, that is for this case is equal to 0.5625 meter per second square. Okay, so this is the answer of the first question. Okay, for the second one, we would like to find time. Okay, for the case of time, we know v0, right? Okay, and now we know acceleration already. Okay, so then we can determine for time. Okay, this is for this case, we use v equal to v0 plus at, and it starts from rest, so then v0 equal to 0, right? And v is equal to 15. Okay, and it's equal to 0 plus a equal to 0.5625 t. Okay, according to this equation, we can solve for t. that is t equal to 26.27 seconds. Okay. Oh, sorry, 0.67. Okay, this is the answer for this problem. Okay, so then next video we will solve another basic problem. That is, we will still with the case of constant acceleration also.